So we come to the second part of the lab. In question 2, we have to apply the support vector machine classification in like three cases. The first one is using the kernel function poly. Kernel function poly has a special parameter called degree. When the case is degree is equal to 4, we will try to apply those data we used above, like X test and Y test, to test whether the model whether the model is accurate or not. In this case, for the first question, we're using like, okay, that's what I showed you now, and I named the model called classification 1 and name the model 2, which is using the kernel function RBF classification 2, and then print out their accuracy using the same data, so we can do some like comparison. But that is not the case. In the third question, I will I will use like SVR. It's one kind of support vector machine, but they combine something like regression stuff. We import some required model like cross validation predict, cross validation score, that will increase the accuracy for the model, because in this question you have to change the value of C parameter and the value of gamma parameter. Just ignore these two lines, and yeah, so what I did is just creating a nested loop. The outer loop is using I represent the C parameter, and the inner loop is using J to represent the gamma parameter. The range I choose is from 1 to 10,000. It's kind of big, but it's so obvious. I mean, when we visualize the data point, visualize the graph, then we can see the graph is changing a lot during those data point change. So first what I did is I assume we're using the RBF kernel function and set the C is equal to I, gamma is equal to J, and use the predict function for the cross validation predict. That's not that's just something for like graphing, and we use the score to evaluate the accuracy of the model, and use the main score to catch the mean value of the score. Like that can be more representative if you don't really want to get a bunch of huge datas. You just take the main, I mean average value to evaluate the model, then I think that will be better. Plus we are applying the cross validation. The error estimation will be a little bit more, a little bit a little bit low, and lower than the expectation. Yeah. After each time the loop iteration, we appended those main score in such a list called RBF SVR score, and then we plot all the point at the end of the loop. Use a legend to visualize it and name the X label and the Y label, and then show the graph. So okay, I can run the code for this time, and then we can see what happened. In this case, they will first output two accuracy, right? The first one for the poly kernel function, and the second one for the RBF kernel function. Yeah, and we get a graph there. So it looks like a two-dimensional graph, but actually it's three-dimensional. So we have C for one variable, the gamma for another variable, and using the score like the label. They're changed by the gamma and the c, those graphs, those curves, and we can conclude something which I have already written in the report. So due to the time limitation, I won't explain it anymore there. But yeah, thanks for listening.